Okay, in this video I'm going to continue on with exercise 6b of the book Fundamental Applied Mathematics. We're on page number 162 and the question is 2. It reads: a particle of mass m swings at the end of a light string. Its speed is 2 meters per second at the lowest point. Find the greatest vertical height to which it will rise in subsequent motion. This is an excellent example of the law of conservation of energy. So what I've sketched here is kind of a ceiling, a pendulum, and the pendulum at another point. Okay, obviously the length hasn't changed, just the angle has changed. And what we're trying to do here is use conservation of energy in order to work out the height to which it rose. So I'm going to say that this is h. That's the height. Now the important thing about gravitational fields is that you can choose the 0 point to be anywhere. Alright, that might sound mad, but all you're doing, everything is going to be delta U. The change in gravitational potential energy is really what you're using, or the change in kinetic energy. So where you say 0 doesn't matter. So say if I say this point here is 0 grav. That means this is plus up. If you go upwards you're getting positive, and if you're going downwards you're getting negative gravitational potential energy. So in this case I'm going to define the gravitational potential energy to be 0 here. So this is going to be U grav is equal to 0. And up here it's going to be U grav is equal to whatever it is. And we know the height is h. We know if it's at its maximum oscillation, you could say it's come to rest. Think about a grandfather clock or a pendulum clock. The bob comes to rest at the top of the motion, and V down here is equal to 2. So let's apply the principle of conservation of energy, or the law, I suppose, of conservation of energy. So we're going to get that KE1 plus PE1 is equal to KE2 plus PE2. So it's going to be half m times 2 squared plus mg times 0 is equal to, now remember I said 0 because this is the 0 point in the gravitational field, so its height is 0, we'll say. It's half m0 squared plus mgh, because we don't know the height of the at the second potential energy point. Okay, so this is going to be equal to 0 and this is going to be equal to 0. So if you're thinking about this with a bit of a physics hat on, you'll see of course that the kinetic energy is being completely converted into gravitational potential energy. And that is of course, because we're not taking into account things like air resistance, but to a good approximation, in a gravitational field, when something is thrown up, it's converting all of its kinetic energy into its gravitational potential energy. Alright, so let's go ahead and do this. We're going to get that, what's this going to be, 4m over 2 is equal to mgh, and then we're going to get h is equal to 2 over g meters. Alright, so thanks for watching. Please pass it on to your friends and subscribe to my channel.